All right. I think we're about ready to get started. We ready to get started? Okay. Let's get started. Welcome to it's got a really long title. Welcome to basically evolving TFS from a box product into a service. And, well, that's what the title sort of tries to convey. I'm really grateful that you've chosen to spend an hour with me here this morning. If you have any questions, feel free to ask questions as we go. It's a big room, so I got two lights shining in my eyes, so hopefully I'll see folks asking questions. So my name is Buck Hodges. I'm Director of Development for TFS and MSDN. Here's my contact info. I used to write quite a bit on my blog. I don't write so much anymore on my blog, but I've spent a bit of time on Twitter of late, looking for feedback, for example, on TFS 2012 and on TFS Preview. So I'll tell you a little bit about my background. So I actually don't work here in Redmond. I work in North Carolina. The TFS team is split half and half between Redmond and North Carolina. This is a picture of the building that I work in. I actually ripped this off from, borrowed this from Google. Because they actually had the picture with the little sign up in the corner of the building, and it actually is fall there, so the trees are red, kind of looks like what it looks like now. So I've worked on Team Foundation Server since the beginning. I joined in April of 2003, and at that point all we had was a command line spec for something called Hatteras, which was the code name for version control. I spent the first 3 years as a dev on version control, and then was lead on team build, and then later dev manager and dev director for TFS. So I've worked on the product since the beginning. I love TFS, and it was great when we shipped V1. I spent 3 years working on version 1. Version 1's always exciting because you build something from nothing. And we've kind of done that all over again with the service. Now we're doing something that's brand new, and it's really exciting, and I want to share that journey with you today. So what are we going to talk about? So the first, I'm going to start off sort of setting the context here with what I call the box and the service. Box meaning the on-premises product, and the service meaning TFS Preview. I'll talk a little bit about planning, how we do planning for the service. Talk a bit about Scrum, which is something we adopted for the TFS 2012 development cycle and really feeds into a core part of the story around the service. Talk about the cadence in terms of how we ship, how often we ship. The engineering system, some of the things that we've had to do and change both in the product and in the tools and all in order to deal with producing a service that runs on Azure. So first, the box. So TFS, being a box product, was developed on a multi-year cycle. So the first release was 3 years. All the rest of them have been 2 to 3 years. 2.5 years for subsequent releases. And so it's a multi-year cycle. The development process was to use milestones and stabilizations. And this, Microsoft's a big company. There is no one way Microsoft does anything. But for developer division, this is the approach that we had traditionally used. So with the milestones, there's this time where you can do development, and then there's stabilization, and usually there are multiple milestones, and then there's a really long stabilization period before you ship. And one of the things that does is it encourages a rather unhealthy behavior. Hey, if I don't get a feature in today, this feature isn't going to see the light of day. It's not going to get into customers' hands for 2, 3 years down the road. Okay, and I've got this long stabilization period, so I'll put as many features in as I can now, and I've got stabilization, so I've got time to fix it, right? So we build up a bunch of debt, and inevitably, this graph here is from TFS 2010, which is actually better than 2008 and 2005 were. But you can see we hit a peak of almost 2,000 bugs, 1,800 bugs. And each one kind of drives down. And as it goes down, you can see where we released Beta 1, and Beta 2, and then RC, and then RTM. But we were in this unhealthy mode of how we develop software. So jam a bunch of stuff in, spend a bunch of time fixing it. And every major release, we'd have some fire. There would be something that needed major surgery in order to kind of finish it off for the release. So we needed a better way of working. On top of that, we already had this desire to change it for TFS 2012. And then we also decided we wanted to provide TFS for everyone. TFS over the internet so that you can get to it anywhere. You don't have to set it up. You don't have to run it. We do that for you. We take care of backing it up, take care of upgrades, sort of all the pain that you have if you're going to run any server product yourself on premises. And so we started with a demo at PDC in 2010. Brian Harry did a demo of really what was an early prototype of TFS running on Azure. And then in April of 2011, we actually deployed the service for real for the first time. TFSpreview.com became a real thing. But it was still hidden. Only a few people could get to it, and we started inviting people to try it out and sort of work through issues. And then at the Build conference a year ago, we announced the service and provided invitation codes for people to be able to come in and use it. And then finally, this past June, we removed the invitation codes. And so how many people have tried TFSpreview.com? Oh, man, that's awesome. So great. And for the rest of you who haven't, give it a shot. And for the few of you who haven't seen it, this is at least what the web experience looks like. So you can hook up Eclipse with Team Explorer Everywhere or Visual Studio or whatever to TFSpreview.com. And this is our web experience, so showing the home page for a particular project. So the tiles there give you some status, the burn down chart, and so forth. But having this service meant we had to change. You can't, you could, in theory, ship a service every 2 years, but nobody's really going to like that. So again, there's the need for change. So I'm going to switch here a little bit and talk about planning and kind of walk you through sort of what we do there. The first thing we want to do is we want to set some sort of vision. So what we do is we set up an 18-month vision and basically do a set of storyboards around it that are intended to convey direction and intent. They're not literal. We're not literally going to go build exactly what it shows, but it gets everybody in the team on the same page. TFS is a large team. It's 130 people, and we'll talk more about what impact that has later. But if you're gonna build a set of coherent experiences, you need everyone to be on the same page with respect to where you're headed. But we're not married to it, and this will evolve over time. It's not like here's an 18-month plan, and we're not going to touch it for 18 months. It's very fluid. So then we have 6-month increments that we do planning and themes. We also call them big rocks internally. It's like, what are the big things that we want to accomplish in a given 6-month period? And we line that up with Azure. Azure has basically spring and fall releases. Spring's anything up to about June 30th, and fall goes to December 31st. And so we define what are our big rocks. So I'll give you an example of one. I mentioned earlier that in June we removed the invitation codes, and we call that Go Big. And so we had a bunch of work that we did to make sure that we could scale and continue to grow the service with greater adoption. And so that became a theme for that 6-month period. That was one of the themes. Then, I mentioned the team is 130 people. We break it down into feature teams. And a feature team is basically something that owns a major feature area. So version control is a feature team. Work item tracking, build automation. These are the feature teams within TFS. And each of those teams owns a backlog, a prioritized backlog for their area about what they're going to build. And as you might imagine, we use TFS for that because in 2012 we introduced a prioritized backlog feature. And the last thing I wanted to mention here was feature flags. So this is both an engineering thing and a planning thing. We use feature flags to be able to say, okay, I want to develop a feature, but I don't actually want it to show up when I ship. So there are features right now out on TFSpreview.com that you can't see, but they're there. And we use that in order to be able to either ship something that isn't quite ready and get feedback on it, or more particularly, it's some major feature that we want to align with a marketing event. So we use it to be able to decouple engineering from when we launch features. The other thing that it's very useful for, like I mentioned, we would do ship out features that aren't quite ready yet because we do features that sometimes take a long time. So it's very, very useful to be able to keep the code all together but not have things show up that aren't ready. So that's a bit on planning. And then I want to talk a bit about Scrum. We adopted Scrum for the TFS 2012 release. And you saw earlier sort of some reasons behind that. We had it was an unhealthy development cycle with building up debt. So we wanted to fix that. So our number one reason for adopting Scrum is to be able to deliver features incrementally. That's fine. That's, everybody wants that. It's a standard part of Scrum. But for us in particular, we also wanted to work like a customer. Scrum was sort of taken over as the dominant process methodology, and we wanted to go build a great Scrum experience in 2012. So what better way to do it than to go live it? And this is one of the great things about working on a product that's geared toward developers. We're all developers, so we're working on a product that should meet our needs as well. And then in terms of the team, I mentioned earlier the team's 130 people. To give you an idea of what a feature team looks like, a feature team is an order of about 10 to 12 people. So half dozen devs, 5 testers or so, and 1 or 2 PMs. And that is the core that actually executes Scrum. So daily stand-ups, the retrospectives for the sprints, all that sort of stuff. That's all done at the feature team level. We don't do that with 130 people. So in the process of converting over to Scrum was rather involved. We did training for the entire team. As many of you know who've tried to introduce Scrum to a team, it takes a while for people to internalize it. It took multiple sprints for the team to be really productive with Scrum. So it's a big shift, but it was well worth it. In terms of sprint length, we went with 3-week sprints, and I'll talk about that a little bit more in cadence. But when we made the decision at the beginning of the 2012 cycle, it was really around, okay, we need a balance between a short sprint and too much overhead. In other words, with 130 people, at the time, the way we were doing development is we'd use feature branches to go off and develop new features. Those feature branches would have to integrate up into the main branch and also pull bits down from the main branch at the sprint boundaries. So if you're, with the sprints being too short, the overhead becomes too big an issue. Certainly if the sprint gets too long, then you lose one of the key advantages of Scrum, which is the ability to course correct very quickly. You don't want to go working for months or weeks on the same thing and not have that opportunity. So we settled on that as a good balance between speed and agility and what we needed to run a large team. So with 130 people, like I say, you can't do Scrum with 130 people. So how do we run the team? We don't do Scrum with Scrums, but one of the things that we do is we use what we call sprint emails. So at the beginning of a sprint, team sends each feature team will send an email with, hey, here are the user stories we're going to go tackle in this sprint. So they provide some context on what they're doing and why they're doing it. And then at the end of a sprint, each team sends a sprint completion email. And again, with this being part of the original of the 2012 cycle, we're not shipping at the end of each sprint. So this was a great way to celebrate completed software. It was a great way to keep people informed. You could watch the demo videos and you could see what each team had built for a given sprint. And that worked out to be quite effective to keep the team on a good rhythm and was successful in 2012. I showed the bug chart earlier for 2010. I'm not going to show one for 2012, but it was much better. The peak was about half as high. So we did a much better job with the 2012 cycle. But again, we're not shipping all the time with the box. So talking about cadence and sort of how long we take to ship, when we introduced the service in 2011, we realized we need to change how we think about shipping our software in terms of the speed. Again, you don't want to you don't want to update a service every 2 years. It has to be much more frequent. And so when we started thinking about this, we were very influenced by our own box thinking. I mean, after all, we've been an on-premises product for years. So we started thinking about, okay, we're going to do major and minor updates. But in reality, what happened was every update was major, and there were problems. I've got a timeline down here. I don't know if you can read it or not, but on the far left is the release of 2010. And then the next one is the April 2011 release or the initial deployment of TFS Preview. And then the next deployment was about 4 months later. It was in preparation for the build conference last year. And then you had the build conference, and then there was another update that we did in December. So basically we went from 2010 RTM to the service deployment in April, and then from April to August, and then August to December. With each one of these deployments, we had problems. Why did we have problems? Well, because there was so much change. The entire product, I mean, again, you got 130 people working on a product. There are actually other people that deliver into TFS, like the test and lab management folks that aren't officially part of the TFS org. So it's a lot of people feeding this software in. And 4 months is a lot of changes. So we realized that the fundamental problem being so much change that we needed to ship more often, that reducing the amount of change in each update would actually help us quite a bit to produce more, to have more reliable updates, more reliable upgrades. And so we thought, hey, let's ship every month. And of course, somebody quickly pointed out, hey, wow, that's 4 weeks, and we have a 3-week sprint. That's kind of weird. Let's do it every sprint. And so we said, okay, that's exactly what we'll do. So every sprint, we're going to ship working software, basically live the ideal of Scrum. And so to do that, you got to set some rules. How are you going to manage this? Well, with the service, with Scrum, what we said was at the end of every sprint, your work has to be done. You have to be ready to ship. And so you can disable it. You can have it behind feature flags, but it's got to be ready to go at the end of every sprint. Then the other thing that we had, that I talked about earlier, was we had this notion of milestones and stabilization. And so in laying out our sprints and deployment, we decided we wanted to have 1 week of verification, which is to say 1 week where we can find ship stopper bugs, major problems. And it's very important that this is not treated like stabilization. This really is, you're done, and we're just making sure that we haven't missed anything that's critical. So we end the sprint on a Friday. We merge the code into the branches on Monday, and then we spend that week doing verification, and then the following Monday we deploy it. So 3-week sprint, 1 week of verification, go live. And this drives a much healthier behavior. The reward for doing a great thing is that you get to ship. And so now there is no stabilization, I'll do it later. There's no, I'll just jam it in now and I'll fix it later. There's no need to do that. You're shipping all the time. So I want to pause here and ask and see if anyone has any questions. Yes, sir?
So are you doing, because you have testers on those teams as well, so during your sprints, are your testers, what are they testing? Are they testing what is being built, or are they testing the previous, or what's the function during that sprint?
So that's a great question. So the question is, what are the testers doing? Are they testing what you're building during the sprint? Are they testing the stuff from the last sprint? What are they testing? So the testers are indeed part of the sprint plan. If you're building something that's barely fits within a sprint, of course, if the devs go all the way to the end of the sprint, it's very hard for the testers to test it. So a lot of times what happens if something fits entirely within a sprint, so you can do the dev work and the test work and be done in 3 weeks, then great, that will go live with that next deployment. If, on the other hand, you need more than that time to get through the testing, then that feature will either be disabled or be behind a feature flag for that next deployment, and then you'll finish the testing and obviously the devs fixing the bugs and be ready for the following deployment after that. So it kind of depends on how long it's going to take to finish the feature, but if it's not ready, we'll just disable it or hide it behind a flag. This also, in the same vein of the question of how do you operate with test, one of the things that we had found in the previous cycles is it became easy for devs to get way ahead of testers. And this approach of finishing software, getting it to a shippable state, keeps dev and test much more closely together in terms of time. So as soon as the developer starts writing something, the tester is working on starting to test it. And test will always lag dev by definition, but the lag is much shorter and much more manageable. Go ahead. You.
Let's say you're working on like the whiteboard, and it's a big change. Like you're gonna put signal R behind it or something. Now, from what you just said, they're not necessarily fully testing that. And so, do you completely like put out a separate copy of the code so that, in other words, if you just have to feature flag it off, the old whiteboard is still there?
Okay.
How do you separate the versions?
So that's a great question. So the question was, if I'm going to do something really disruptive or really major, so in his case was, hey, I've got some sort of whiteboard on the site. I'm going to put signal R behind it. I'm going to make some major change to how it works. How do you manage that? And I'm actually going to talk a bit about that in the engineering section. So if I don't answer your question, come back and ask it again.
Mine was sort of related. I was just asking if all your developers are really working in your trunk branch or they're branching out.
Okay, that's another great segue to the next section. So he was asking, where do all the developers work? Do they work in the main trunk or somewhere else? Any other questions? One more. Okay, so the question was, we've got verification week. We discover some major problem. What do? Do we delay the deployment, or do we fix it, and how do we do that? So the answer is we go fix it. We started deploying every 3 weeks back in January. We did actually miss one deployment in the spring where we chose to cancel it because we had some major issues that we couldn't address in a verification week. But outside of that one anomaly, what happens is we file a bug, and we have an email alias that we call ship room that people send email to and say, hey, I need to fix this issue. They describe what the problem is, what the code change is, what testing was done on it. Because again, this stuff's going to go live, so you want to make sure it's thoroughly tested and works well, gets good code reviews. And then you check it in, and we use a branch that ultimately becomes production during that week. And so you have to go create a workspace in that branch, make your change, build it, get it tested, and then you've still got the opportunity to get it fixed before we deploy. Like I say, if we were to run into that same situation again, we've only had it happen once, but we would pull the deployment. It's not on rails to the point that's like, if we don't ship, it's total failure. Actually, a bigger failure is shipping the wrong thing, shipping a mess. And so if we had a major problem, we'd hold it. So engineering, I want to transition over to that because I think it's going to answer a number of questions that are on people's minds. So we have the service in the box. I had mentioned that earlier, box being the on-premises product. We use the same code base for both. And that is both good and it's bad. It's good in the sense of we have one team that we don't have a sustained engineering team. We don't have anybody else who works on the code. It's just the TFS team. So as a result, if we had two code bases, one code base for the service and one code base for the on-premises product, it becomes much more difficult to work. You've got multiple different systems, multiple different branches. However you want to structure it, it starts to fragment your team. So we keep the team together. We keep the code together in order to facilitate that. We made a change from what we did in 2012. So earlier I mentioned we would have the main branch and feature branches underneath it. For the service, we've said, okay, there's overhead to creating a feature branch. Once you go into a feature branch, you got to have your test infrastructure and everything else set up to work in that branch. It's not a free thing. There's no free lunch. So we said, okay, we're going to change the philosophy a little bit, and for anything that's not disruptive, we're going to do it in the main branch. So if you're, let's say, adding a new feature to the web UI, if you're adding a new feature to version control, if you're adding a new feature to build, just do it in the main branch. Now, if you're going to go and do something much more potentially disruptive, then go ahead and do that in a feature branch. And I'll give you an example of that. If you were going to go make a schema change, for example, to version control, to the database, that you do that in a feature branch, make sure it all works well, and then push that back up. So since we got a bunch of people working in the same branch, how do we manage that? We do that using two things. One is gated check-in, and the second is a rolling test system. So gated check-in is a feature that we introduced in TFS build back in the 2010 cycle. And gated check-in allows you to, I think it was 2010. Anyway, gated check-in allows you to submit your changes. The build system will build them, and if they build, or if you run tests, if they pass tests, they'll be checked in. Now, in our case, the build takes about 20 minutes, and obviously that 20 minutes stands between you and having your code in, so you want that time to be as short as you can make it. But our tests take longer. Our rolling tests take 2 to 3 hours. This is something ultimately we'll have to speed up, but they take a few hours. So we said, okay, we're gonna balance out protecting the branch and optimizing for quality here. So when you check in, you go through the gated check-in system, make sure that it builds. So anybody doing get latest will get buildable code. And then the rolling test system is running in the background, picking up all the changes that have gone in since the last time it ran, and it just runs all the time. And in the next slide, I'll show you how you as a developer would see the outcome of that. So I mentioned earlier about disruptive changes. You do them in a branch, and we said, okay, in order to be able to ship this thing consistently, we need to have those disruptive changes come in at the beginning of a sprint. So even though you go off and you do this in a branch and you're done when you integrate, we all know that, well, you might be done, but there's a possibility that you overlook something, that you missed something. So integrate at the beginning of a sprint. You got the rest of the sprint to find any critical issues, and then, of course, verification week, which you shouldn't need. So we changed that philosophy, again, to help lower the overhead to working in the team. So at the end of a sprint, when we're done, we merge to the production branch for the service, and we also merge to a branch that we use to deliver the quarterly updates. As many of you hopefully know, we're producing updates now each quarter for the 2012 product, and that includes both Visual Studio and Team Foundation Server. So with this upcoming quarterly update, and you can certainly download and try the CTP now, you'll get the same features that we have in the cloud. So for example, we added Kanban to TFS Preview back in August. If you get the quarterly update, you'll also have Kanban for your on-premises TFS server. Question?
For the gated build versus the rolling test, are you using a priority attribute on the unit test to decide what tests run gated and what tests run rolling?
All right, so the question was, are we using any kind of priority in order to know what set of tests to run in the gated build and what set of tests to run in the rolling? And the answer is no, because we actually run no tests at all in our gated check-in system. We said, okay, it already takes 20 minutes to do the build, and we want to minimize the amount of time to get in, expecting that people will test their code. This is a clear expectation we set with the team. You got to test your code before you check in. So the rolling tests are there to catch anything that slips through. They're not meant to be a crutch or any kind of safeguard. So the one thing that we do, the reason we use gated check-in is if you have enough people working in a branch, and everybody's doing a great job, but they only break the build maybe twice a year. Well, when you've got hundreds of people working in the same branch, your build's going to be broken all the time. So we said, okay, it's easy enough because it's easy for somebody to forget, hey, I meant to add a file. Whoops, I forgot to check it in, and everybody thinks it can't build now. So that's the trade-off we make there. Is really one of a balance of speed and safety.
Do you run like any other tests on the gated check-in? Do you run like FXCOP or
No, so the question was, do we run any tests? Do we run FXCOP? Do we run anything on that? And the answer is no. It's just straight up. Do the build, check it in if it builds.
What's the specs of your build server?
Haha, specs of my build server. Let's see. We bought the build machines about 2 years ago now. I honestly don't remember. I do remember, they had enough RAM. We actually set up a couple hard drives as a RAID 0. I'd like to actually move them over to SSD, just haven't gotten around to it. It's not a great answer to your question of what our build server, how our build servers are configured, but that's kind of what I remember. Yes, sir.
Do you do automated versioning of all these as you do your automated builds? And how do you keep that together between all these different feature branches and then the various like production or ship branches?
Okay, so how do we do versioning, and how do we keep it in sync across different branches? Okay, so the versioning is done every night when we do a nightly build. The version number is checked in as part of a header file. So it only happens once a day, and then the sub branches like the production branch, it doesn't actually create a new version. It just uses the version number that came down when we did the merge. So we've only got one thing effectively, if you will, that's creating a version number. So we don't have multiple version numbers running around. Now, if you're in a feature branch, it does mean that, like if I say I've got version, well, the versions that we use are date based. So let's say it's 5, 10, 26, or whatever the number might be. Well, if you can have that same build number in a branch as well as in the parent. So you have to know both the branch and the build number to fully distinguish where the bits came from.
And do you manually increment a minor number every time you do one of these like quarterly updates, or?
So do we increment the version number when we do, for example, a quarterly update? And actually the answer is no. The quarterly update, and this is the same as RTM and RC and all the other releases, they get whatever build number was the build number when we were done, which is to say whatever the final build is, that's the build number. So that they're never set by hand, if you will. Question?
the disruptive changes? Does that really carry over into 2 sprints, one development and then one the check-in and then the assertion of that?
I'm sorry?
If you're doing a disruptive change, are they developing in one sprint and then checking in at the next sprint to merge into the next sprint?
I see. So the question is, if I'm doing a disruptive change, how often do I integrate back up into main? And the answer is you don't integrate till you're done. Now, in order to but at the same time, we don't want people going 6 months in a feature branch before you RI. So there is a balance there that we try to strike between finishing out the feature. Maybe you'll be a checkpoint at which you bring it up where you've got part of the features available, but you're not going to do any harm. Either the rest of it's disabled or hidden or whatever. So there is a balance to be struck there, but we also require that feature branches take periodic merges from main, so that let's say you go 3 sprints to do a feature in a branch, that you're not getting all the way to the end and go, okay, now I got 9 weeks worth of changes to pull down from main, because that would be particularly painful. Question?
Question back on the topic of cadence. So I noticed in the diagram on the timeline, when you had the verification was overlapping with getting the next sprint. How do you, from a capacity planning perspective, factor in that in the developer's time to deal with this? Is there anything that comes up during that verification?
Okay, so it's a great question. So the question is, hey, I see that your verification week overlaps the first week of your next sprint. How do you deal with that? How do you plan for it in terms of capacity? And the answer is it's inherent with the notion that verification week is truly for finding sort of last-minute issues, showstopper issues. So by having it overlap with the first week of the next sprint, we're emphasizing that you really were supposed to be done at the end of the previous sprint. And basically, at this point, people have adapted to it. You realize, hey, I got to plan my sprint such that I'm done, I'm ready to go on the Friday when the sprint ends. So as a result, there is some disruption, and it does hurt people. Like you commit to something in the next sprint, and then suddenly you do find you've got some showstopper issue to deal with during verification week. It does take away and does disrupt the next sprint. So it's a balance, and in part it's just to reinforce the message that, hey, we expect things to be done at the end of the sprint. And the tests that we run are automated. So there's not like it's not like we take the test team offline during verification week and have them just focus on verification. Automation is a huge part of pulling this off. Yes?
Buck, Brian Harry recently blogged about that you changed all the web UI to TypeScript. Can you tell us why you did that and how it went? What was the experience?
Okay. So this was kind of tangential, I guess, to a lot of this presentation. But the question was, okay, he saw the blog post that Brian Harry did on converting TFS over to TypeScript, because we have a lot of web UI. We have about, I think it was 80,000 lines when we counted it, if we subtract out spaces and comments and all that sort of stuff. So we converted over to TypeScript. And this was an effort that took us, wow, I don't remember exactly. We've probably been working on this for 8 weeks or so. I mean, it was a while. And we actually wrote a tool to do a lot of the tedious work to convert, because we had, and Brian mentioned this in his post, we had JavaScript doc comments that would had type information for the parameters, for example, to a function. So when we ran this tool, it could convert and create types in language. But TypeScript, for those who aren't familiar with it, is it's a language that compiles into JavaScript. You can mix JavaScript with it. It is JavaScript, and the whole premise is to enable JavaScript for large application scale development. With a very dynamically typed language like JavaScript is, if I make a change and I add a parameter to a function, or I change something about the signature, nothing's going to tell you that until you go run it, and at runtime it blows up. So even with the fact that we use JSLint and other tools to try to do a good job with our TypeScript, we found that with our JavaScript, we found that when we converted to TypeScript, we found a number of bugs that we didn't know about. So I'm going to move forward here in the interest of time and talk about the rolling test. So I promised you I would show you what those look like. And what I've done here is I basically sliced up an email. An email for this wouldn't actually fit on one slide, so I took screenshots and sliced it up. And when you check in as a developer or a tester, and your code is your changes are tested, you'll get an email that says how it turned out. So up in the upper left, you can see the trend line. You can see the orange line there was showing that TS Basics, which is our self-test suite, was not at 100%. Then somebody checked in to fix, and then somebody broke it again. And in this particular case, we see that the break is in the XPlat, the cross-platform area. The section here in the middle that shows a screenshot also includes a stack trace. So the email that you get will actually show you some information about how the test failed, at least show you the stack trace in the code, and a screenshot. Sometimes a screenshot can be interesting in its own right. And then at the bottom of the email is a list of all the change sets that went into that test. And that's at the bottom of the screen here, and it was the middle check-in, which happened to be some early TypeScript work. The developer had checked in some changes to the version control web UI that he didn't actually mean to check in yet, and then the test caught it. Test broke. So we found it and backed out the change and got the branch back to being healthy. So what are the differences between a service and the box product? What are the changes that we've had to deal with? One thing is the service scales differently. On the on-premises product, you have collections and team projects. And team projects are, of course, inside collections. Collections are individual databases in the on-premises product. When you went to sign up for an account in tfspreview.com up until this spring, you signed up for an account, you got your own database. You got your own database in SQL Azure. Turns out that's kind of expensive. So at a few dollars a database, clearly this wasn't sustainable. So one of the things that we did is we went and changed it to create what we call multi-tenant databases, basically putting multiple collections inside the same SQL Azure database. And this was an example of a disruptive change. So this was a massive schema change. We went to added a column to every single table to indicate which collection a given row of data belonged to. So that one we did in a feature branch, did a ton of testing on it, and then RI'd it. And in fact, we made that change before RC of 2012. Because again, living in a world where I want the same code base for my service and that I also use in my on-premises product, it was important to get the change in both so that they don't diverge. It was also a change where the upgrade is particularly impactful. If you're adding a column, it's in all your indexes, basically all the tables got rewritten. This is not something you want to ship as an update either. So the service scales differently. We had to think about what that meant for us. And the key here was to think about the cost model. So at $3 dB, obviously can't do that. We also don't want to store content in SQL Azure. So the on-premises TFS, everything gets stored into your SQL database, which is great for backing up. You've got one thing to manage. You've got one thing to back up and restore. But it's really expensive to store things in SQL Azure compared to Azure Blob Storage. So our version control file content, our test attachment content, our work item tracking attachment content, all of that content got moved over to Blob Store. And as a result, we built what we call a file service that's inside the product, such that if it's running on premises, it still shoves everything into SQL, and if it's running in the cloud, it puts everything into Blob Storage and manages it. Question?
Would you change that now with the advent of Azure services for Windows Server? Like, would you look at using table storage instead of, or is that so radical a departure because you guys cube it and report on the data and stuff like that?
Okay. So the question was, would we ever consider using Azure Table Storage for the data? And the answer is no for two reasons. So in the case of the file content, there's no need to query on it, so putting it in blob storage is the best place. For the metadata, we do a lot of heavy SQL queries on it, joins, and so forth, and that would not perform well on Azure Table Storage. So Azure Table Storage actually plays another role in the service, which is the backing for Windows Azure Diagnostics. So they've got a whole bunch of data that goes into it, but it's not the operational data, if you will, for TFS. Another difference with the service is since you're being able to ship all the time means that you can react quickly to problems, including customer support issues. Number one support issue for TFS preview was, how do I change the account owner? And this was the number one thing people were calling customer support for back this summer. So we went and scheduled the work, did it in a sprint, and shipped it, and now you can go change the account owner yourself. So that one's gone. Then the next one comes up. I want to rename my account. I don't like the name I picked. Well, we've yet to fix that. We've got that on our backlog to fix soon. But that's now our number one support item. And so since you ship all the time, you can react to issues that come up. And customer support, just like operations, is an important cost in your cost model for running your service. So you want to make sure you deal with these issues and not end up having to increase the number of people that it takes to run your surface. Online upgrades. So those of you who've upgraded TFS before on premises know that you shut the whole thing down, you do your upgrade, you bring it all back up, you do it over a weekend. How many people would like it if tfspreview.com shut down for a day? Yeah, not so much. So early on, our original upgrades were exactly that. We'd take the service down, we'd do the upgrade, and we bring it back up. But there's never a good time to take customers down, particularly with global service. So we had to invest in doing online upgrades. And we started off with, okay, we'll have the configuration DB be down, and that's global downtime, but for a few minutes to do the upgrade, and then we'll roll through the accounts, and you'll only suffer downtime for your account. Then we got the configuration DB such that it was done as an online upgrade, and now you just had individual account downtime. And then the last step that we completed a few months back was we'll get everything fully online. So there is no downtime unless we have a bug. And, well, we've had a few bugs. Some of you may know that we had a deployment in September that had downtime and a deployment in October, early October, that had downtime. So, you know, again, when I started this presentation, I said this is about our journey, and this is, you know, we're still growing, we're still getting better at it, but we still make a number of mistakes. And online upgrade is both extremely important and kind of hard. The next thing that's really important is automated deployment. And when I say automated deployment, I mean in a couple of ways. One is you want your deployment automated such that dev, test, operations, everybody's using the same deployment tool to deploy your service. So you don't get to production and go, oh, well, it wasn't a problem in testing, or it wasn't a problem in the dev environment because we did it differently. So you want that deployment owned by dev so that when you check in, your deployment always works. There's not somebody else who has to come along behind, you know, either from QA or for operations or something, and clean up deployment. And then in the early part, you know, I talked about the cycle. We did multi-year cycles for the product. For the on-premises product, you go through some 2.5 year cycle, and then you're done. You ship it. There's this kind of break, if you will, between product cycles. And so we'd use that time to do engineering work to improve either the code base, the tooling, change processes. I mean, this is the time period, we called this milestone quality. This was the time period that we used between 2010 and the 2012 cycle to adopt Scrum, for example. Well, with a service, and if you're shipping all the time, there's no downtime. So when do you do this type of work? And so what we've done with TFS is we've created an engineering backlog. And so we have a prioritized backlog. It's basically a virtual team that owns it. And we make sure that that as we progress, we spend some portion of time in every sprint making something better in the engineering system. You know, Adam asked earlier about TypeScript. TypeScript was one of the things that was on our engineering backlog, and we have just here lately completed that. We have had other things like, you know, adoption of JS Lint. We're moving our source code around, trying to clean up some of the sort of the artifacts, if you will, of almost 10 years worth of software development. So those things all go on an engineering backlog. So another big difference and an important one between a service and on-premises product is the team is now running a service. You're responsible for a live site. And this is a cultural change. You're not building software and then shipping it, and then somebody else has to deal with, okay, the network went down, the disk crashed or whatever. Sure, we're running on Azure, and we get to rely on Azure for things like disk crashes, fine. But you're responsible for the software. If the software goes down, then you're the one who's got to go fix it. So, and you don't want to, you know, if you do have a problem, you want to react quickly. And I'll talk a bit about that here in a few minutes. But it's a cultural change, getting the team to absorb, hey, you're running a service now. It's not just writing software and shipping it, but you're actually on the hook for making sure that the customer has a great experience every single day. We have extensive tracing now in the product. This was something that we had to add. In a world where you're running the product you know, on premises, so you say we're running on the developer division server, or you're running it on at your company or whatever, you have a problem, somebody calls up and says, oh, well, send me a dump, do a process dump, or attach a debugger. And these things are much harder to do in the cloud. So you want to add tracing, rich tracing into your product to be able to debug issues. Again, this was a fairly substantial change for us in terms of how we worked. You also need to create alerting. So you want to know about a problem as soon as it happens. And so you've got all this data coming back out of the activity log, the event log in Windows, your tracing. You want to be able to hook up rich alerting off that to find out about problems quickly. One of the funny things about that is, so we've got alerting for the build feature. Many of you hopefully have tried build in the cloud. Well, we had an issue, in fact it was an issue with some Azure infrastructure. Something went wrong, and we had a retry loop in the build code. And unfortunately, when the code got written, because I asked somebody how this happened, it's like, well, I was writing it and I got distracted. And they forgot to put the delay in there in the retry loop. And so it just starts spinning like mad, firing alerts, and it just flooded the system. And so this is also one of those things where sometimes you surprise yourself with bugs that actually, they don't really affect the product, but they end up affecting your ability to see into the product, to monitor it. And that was one of those incidents where you go, how did this happen? But it's easy enough to do. It's just something you miss. So it's important to test that in your development cycle. And then the last thing I wanted to mention, and then I'll take a question, is external monitoring. External monitoring is important, but it's not sufficient. So we use Gomez, for example, to monitor the performance of the site, whether or not there are problems. Like we've got dependencies, obviously, on ACS for live ID and that sort of thing. So we use Gomez for that, but it's really important that you have extensive internal monitoring. Our Gomez monitoring is every 5 minutes. Well, a lot can go wrong in 5 minutes, and you'd much rather know before 5 minutes is up, of course. Question?
Yeah. How much of this is proprietary? How much of it, I think you mentioned Gomez, we use like Nemo. How much of it is proprietary versus, obviously, like putting tracing into your own code is important. And then you're saying that goes to Azure Diagnostics?
That's right.
So you're reading it out with the standard Azure Diagnostics, or did you build your own dashboards?
Okay.
How much work went into this?
So he's asking how much of this is custom versus using sort of off-the-shelf tools, and I'll talk about dashboard in fact in the next slide. So we use Gomez. Basically, the rest of the stuff that we use is largely internal, except like the Windows Azure Diagnostic stuff. We're using the same core functionality there that you could use in your own service. So we try, in other words, we try not to reinvent anything, because obviously that could be wasted effort. Speaking of dashboards, we have a dashboard. And I was talking earlier about the importance of cultural change. And I took this picture literally on Friday. This is, again, the North Carolina office. We have well, it's not a cafeteria. It's basically a cafe. Place to sit and eat lunch if you brought your lunch. And so I just snapped a picture while I was there. And so we have dashboards both in North Carolina and in Redmond, and just in the hallways, or in this case in a cafe, so people can see what's going on with the site. And it's important to keep that on the front of everybody's minds, that this is critical software. And but there's a bit of a funny story here. So we had a query that we used in the dashboard to look for failed jobs, problems with the job service. And somewhere along the way, we weren't quite monitoring what impact that was having, and we were looking at the performance of the configuration database on SQL Azure and discovered that, in fact, 59% of the load in production was coming from our own dashboard. And man, so that was just a great reminder. It's like, you have to test your dashboard like you test your product code. You need to have your dashboard running in your perf environment, in your scale environment. And it's just easy to overlook those things. And it's like, yeah, okay, lesson learned there. The other thing that we encountered with the dashboard as well, we've got this thing that tracks how many people access the service in the last 30 days. And Brian Harry noticed it was going down. He's like, why is this thing going down? All of our other indicators are good. Users should be going up. Why is this one going down? Well, it turns out somebody made a change to the product about how account information is recorded. And the dashboard software started just not finding what it needed and recording a 0. And so the average was coming down as more and more zeros were factored into the average. And again, we didn't have any tests for the dashboard. So it's like, oh, yeah, okay, you got to treat the dashboard, you got to treat your monitoring software just like you treat your product, and have tests for it and make sure that it's working properly. Question? So how do we deal with backups and the upgrades? So we have backups through the Windows Azure system, but we don't go around and upgrade it, or we don't go through and produce an explicit backup of everything in the system before we do the upgrade. It would take a while. It would add quite a bit to the time to do an upgrade. But we do have the backups of SQL Azure has, and so the key there is testing upgrade. We have a lot of tests for upgrade. We spend a lot of effort on that to make sure that upgrade is very, very solid. And if something does go wrong, then we have to patch it. But our tests now for upgrade, because of the years of doing upgrades with the on-premises product plus the service now, they're very, very good. So you're asking about rolling back a SQL database. Right. Yes, that's right. So there is no rollback. Like you don't get to go, like, the only way you could truly roll back is to go pull the last backup from SQL Azure and restore that, and it can be done. It's a slow process, so you need to make sure it works and works well. Question? What tools are we using to build and deploy our schema changes? The short answer is our own, which is to say, we have SQL tooling that we built ourselves. We have all our scripts. All our SQL scripts are checked in as individual files. We have tooling that deploys those. We have tooling that runs the upgrade. So we don't. It's all custom. Is the short answer. No, we're not using SSDT at this point. Question?
Related to that question, and then also do you have a build team that manages that, or is it up to the developer merging the changes and
Okay, so the question is about who merges the code, and the answer is we do, the product team. So there's a developer who every 3 weeks does a merge into the production branch for the service. Now, as far as the quarterly updates go, that particular branch is managed by a central engineering team in the developer division. So I guess I should rephrase my answer and say it depends. For the service, we do it ourselves. For the quarterly updates, it's done centrally. I'll come back, but I'm going to move ahead and come back to your question here. I got about 3 more slides. VS connectivity. Okay, so LiveSite. So I was talking about the cultural changes and the emphasis on LiveSite, and I thought it'd be interesting to look at our LiveSite review process. So every Tuesday, we have a meeting to go over all of the LiveSite incidents that happened over the previous week. So there's, this being a Tuesday, there's one this afternoon. And there's a slide template that we use, and you got to fill out all this information. I actually took this one. As you can see, the incident date was 10/15. This was real. This was, 2 weeks ago, almost 2 weeks ago today. And the thing that our goal here is to make sure we understand how long did it take to detect a problem, how long did it take to get the right person involved to fix it, and how long did it take to get the fix out there. And this particular one is not a pretty one. It took 21 hours total from start to finish to deal with this. So when we made an update to the service, and that update, and this was a small update, this was a hot fix, and there was a bug in it, and it resulted in some people not being able to connect from VS to tfspreview.com, all because we had a string check that was case sensitive when it should have been case insensitive. Very simple thing. But it's very important to us that we learn from every incident and that we get faster and better at detecting them. Thankfully, many of these don't take nearly this long to detect, but this one was, I thought, a good one to look at. And here we actually saw it from two angles. I mentioned earlier I looked for feedback on Twitter, and I saw somebody was having a problem. They couldn't connect to TFS Preview, and I thought, well, that's strange. And I had them send me email, and they sent me the details, and I sent it off to the team. And meanwhile, the test team had also noticed the elevated error counts on the monitoring page. And we tracked it down, and this was the problem, and we deployed a fix for it. And so part of this is figuring out, so what is prevention here? And the best prevention of all isn't prevention of a single problem, but is in fact prevention of a class of problems. And so the key thing here was that, hey, we need to improve our monitoring to really look at deviations very closely and be able to react to, okay, sometimes you get 404 errors, and 404 errors are normal if somebody hits an URL that doesn't exist. But when they spike, when there's a deviation from sort of the ambient noise, you need to know about it, need to know about it quickly and be able to go investigate it. Any questions? Nope. One? Okay. So what happens when... I see. So what happens when we detect something is wrong? So there are multiple things that we have for that. Some things are email, where the system will see something and send email. For example, we got a lot of email alerting around build, for example. Some of it is done by people looking at it, seeing that there's a difference there. Some things are slow to develop. This is very much an area where we're still developing. So when I said we're still early in this journey of transforming to a service, we don't have our monitoring as fully automated as we ought to. So right now it's a mix. It's a mix of things that are done automated and you get email or a phone call or something on, and there are other things that it's really somebody looked at it and went, oh, this has changed. And when we see that there's a pattern there that we need to automate, then obviously that's one of the areas where we go and make improvements. One more question, then that you in the red. You haven't asked a question.
Who writes your unit tests? You guys have code coverage requirements, and then what happens when you break the unit test?
Okay. So question was, who writes unit tests? Do we have code coverage? And what happens when you break them? All right. So the developers and testers, developers are responsible for writing unit tests when you think of unit tests in the truest sense. When you think of tests kind of in general, it's a partnership between dev and test. One of the problems we had in previous cycles was tests had their tests and devs had their tests, and there was a lot of duplication. So that's one of the things we fixed over the years. So devs are fundamentally responsible for writing unit tests. In terms of code coverage, we do very little with code coverage. We do code coverage to look to see if we've got major gaps. I'm not personally a big fan of code coverage. All it can really tell you is you're not executing a line of code in your product, but it can't tell you anything about the quality of your tests. And so we all know how to we all know how to make code coverage really high. Then you asked what happens when it fails, and that was really the email that I showed from the rolling test system. So that's running both unit tests and larger sort of end-to-end tests that QA has written. And so if you check in and you break one of those tests, then you would see that in the email. And last slide, wrapping up, sort of what are the main things that I'd like for you to take away from this? First thing is shipping frequently. Shipping frequently really drives healthy behaviors. There's a reward for doing the right thing, of building shippable software, doing it right as you go, and not building up debt. Shifting over to running a service is a cultural change. If you have a team that, like ours, is used to box product software, used to shipping every couple of years, somebody else runs your software, it's a big mentality shift to realize, hey, you're responsible. You're on the hook now for customers' experience every day with your software, that you're running the service for them. And I shared some of the funny stories about the dashboard and introducing a bunch of load to the system. It's really important to test the tools. Whatever tools you use to monitor your system, you have to make sure that those show up in your perf environment, your scale environment. That's really part of it. And I want to thank everybody for coming out today. And if you have any more questions, I think the clock says I have about 50 seconds left. But I will be over in the Visual Studio area that's just down the hall right here, and I'd love to chat with people. And thank you very much for spending an hour with me.